So I was playing with different versions of the ROM. There's a whole bunch of different versions, and I was programming a bunch of 27C64s, and popping them out of the socket, popping them back and forth. And I thought, well, wouldn't it be nice if I just had a way to switch them easily? So you can see here that the older Kaypros use 2716s, 2732s, but the universal card uses a 2764, so it has 8K of program in it. And here it is in the circuit, and we can see that there is a certain pinout of a 2764. Let's take a look at maybe upgrading this thing. All right, so here is a diagram of different versions of EPROMs. We have a 2764, and if you take a look at the difference between a 2764 and a 27512, okay, they're both 28-pin devices, all right? And the 64, if we look here at pins 1 through 14 over here, in this column here is the 64, so it's using all the way up to A12, and pin 1 is just tied high. If we look at pins 26, 27, and 28 on this side, the 64 is not using 26 at all. It's a no connect. 27 is a program pin, and then the 28, of course, is VCC. If we take a look at a 512, we have A13 on 26 and A14 on 27. All right. So I want to build an adapter card to use the 512. All right, so I'm going to make a piggyback card that plugs into the socket of the 64. So the left hand is going to be the socket. That's what's there, okay? And again, we have A0 through A12 and D0 through D7. And then we have these extra little pins. We have chip selects, output enables. The 64 has a no connect on 26, and then it has a not program and a VPP, a programming voltage for the part. We look at the 512, it has different pinouts. So what we're going to do is we're going to map them all across. So all of the pins map across except for pins 1. Okay, pin 1 is now going to be A15, and 26, 27 are going to be A13 and A14, which we didn't have before. Okay, I'm going to bring A13, 14, and 15 out to a little header section so we can tie them high or tie them low. So what we're going to do is we're going to have multiple ROMs all in the 512, and then depending on how we have 13, 14, and 15 set, it will use different parts of the ROM. Okay, here's our board. Very, very simple. Going to have pins on one side and socket on the other side. And then we have 13, 14, and 15 as jumper areas. And we'll be able to set them either high or low and be able to choose which part of the ROM we're going to use. So the 64 uses addresses 0 through 1FFF. And if we put a copy of that ROM at 2000 and set A13 high, then it'll go to 2000. If we set A14 high, it'll go to 4,000. If we set 13 and 14, it'll go to 6,000, 8,000. So we can put multiple copies in the ROM, and just by changing the jumpers, we'll be able to choose which ROM we want to be using. Let's see, what would the 3D viewer do? There's the 3D, and you can see it's just going to have a chip on the top, which is kind of weird looking because it's just not right. Anyway, it's not gonna look like that. It made a really, really big chip. That's kind of strange. Um, and on the back side, of course, we're gonna have IMSAI dog. I'm really curious how the program decided to use one big giant chip. It didn't really. It drew two chips on top of one another, and they blended so well. It looks like one big chip. But yeah, they'll just be one. All right. Well, there we go. Get this sent out and give it a try.